So in this example, we want to test your knowledge of how to apply Ampere's law and figure out the total enclosed charge. This figure shows two closed loops, 1 and 2, so in purple and green, wrapped around currents I1 and I2. So those currents are squares, and the left square has a current I1 flowing through it in the clockwise direction, and the second square has a current I2 flowing through it, also in the clockwise direction. So when we take a look at the answer, we have to look at the answers for the two different loops. So we're trying to figure out the value of the integral b dotted with dl. So let's first look at loop loop 1. Looking at loop 1, I want to sketch it out first. Maybe a little bit too much. This is loop 1. And taking a look at loop 1, I know that there is current going down. Oops, let's just do this. There's current I1 going down, and there's current I2 going up. So which one's positive and which one's negative? This is where our right-hand thumb rule comes in handy. Your C, or your dl, is in the counterclockwise direction. So our fingers are going to curl around along dl, and our fingers curl around this way, which means that a current going up is going to be positive. So we have positive here. This means that when I go to solve for the integral of b dotted with dl, I have mu naught times I enclosed. I know this is mu naught. I enclosed is going to be up is positive, so it's going to be I2 minus I1. That is my answer for loop number 1. Now we take a look at loop number 2. This gets a little bit more complicated, but it's not undoable. Let's just replicate loop number 2. It looks something like that. Is this one loop or 3 loops? Technically it's 3 loops, so we kind of have to know whether each loop is clockwise or counterclockwise in terms of its dl. So we know the far left loop goes this way and that way. This is here, here, and then you have this going to the right, to the left. Now we have to take a look at the current flowing through each one. For the leftmost loop, we have current going up. So this is I1 going up. For the middle loop, we have I1 going down. So if I1 going down. And the right loop, we have current going up, and this current has a magnitude of I2. So for each of these, dl is different. So that means I have to determine which way is positive and which way is negative for current flow for each of these segments. So looking at this, dl is going clockwise. So that means I have dl going like this. Which means this is the right-hand thumb rule. In order for dl to rotate clockwise, my thumb has to be pointing down. So down is going to be positive. Now for the middle one, I have a counterclockwise. So I have my dl going counterclockwise. So that means that's my dl. And therefore up is positive current. Now taking a look at the last segment, we have this for dl, which is counterclockwise. So we know that down is positive. So when we try to calculate the integral of b dot with dl, we know it's going to be mu naught times I enclosed. All of this gives us the information we need to solve for I enclosed, and I enclosed is simply for the first segment, we have I1 going up, but that's against the positive current. So that means we have negative I1. The second segment, or the middle segment, we have I1 going down, but up is positive, so we have another negative current. And then for the last one, we have I2 going up, but down is positive, so we have minus I2. So combined together, we have mu naught minus 2I1 minus I2. And that is our answer for the value of the integral for loop 2.